All right. Welcome back to another Pinot Meetup sponsored by StarTree. We are going to be talking some cool things about real-time analytics and Apache Pinot and some other cool things. It's great the folks who join us today, and we have everyone who joined us online and stuff like that. Today we have an exciting talk from Manish. He's one of the engineers who working here at the StarTree, and he will be talking about Minions, which is like a very exciting technology. Before Manish will start, I just want to do like a quick. I didn't mention myself. My name is Victor Gamov. I'm a head of developer advocacy here at StarTree. And please, if you're watching this after recording, join our Slack channel for questions that you might have around real-time analytics and Apache Pinot. And also, we will have a Q&A session after Manish presentation. We didn't test this. If Manish has the ability to share screen, Manish, do you have it? Can you share the screen and go with your slides? Because it's
sure.
it is time for you to do that.
Sure. Yeah. So thanks, Victor. I'm Manish. I'm a software engineer at StarTree. I've been with StarTree for about a year. I got introduced to Pinot when I was at LinkedIn. I used Pinot for one of my projects when I was in the newsfeed team. So that's how I got introduced to Pinot, just a little bit. So I've been working on the data ingestion aspects at StarTree. And today I'm going to talk about Minions, like what Minions are and capabilities of Minions. And I've also been using Minions like for the data ingestion at StarTree. So let's get started. So today this is a very broad agenda. So one is like a very brief introduction to Pinot for folks who are not familiar with Pinot. The second part is I'll be talking about what Minions are and what kind of things that you can do with Minions, like capabilities you can have. So Minions, I mean, if you're wondering, the yellow guys, that's not the Minion here. So the third one is like, if you were to extend the Minion framework to build your own capabilities for your use cases, how would you go about that as well? So hopefully at the end of the talk, the two and three are the key takeaways. You take home like what a Minion is, what kind of things you can do, and a starting point of if you want to build something of your own, like from where you can start. And I'll also answer questions to the best of my ability. And if not, I can take those questions and offline answer over Slack. Thank you. So brief introduction about Pinot. So Pinot is an OLAP data store, a distributed OLAP data store. And the purpose of the Pinot, the reason it was built is to answer analytical queries, which requires large scan of data in low latency, as well as when you have high volume of such queries, you want to get those queries answered at very low latency. And of course, you want the system to be horizontally scalable, fault tolerant, eventually consistency, and so those guarantees as well. If you look at the Pinot architecture, the cool thing about this architecture is it's very, very pluggable. So it works with various types of sources to get the data in, like real-time, offline sources, various data formats. And also the very powerful thing is like the ability to have indexes, smart indexes based on a use case to answer your queries, right, based on the use case. And it's been used for various use cases like measuring KPI, getting the insights, anomaly detection, and even recently, like at LinkedIn, we used to do even like things like model monitoring to monitor the features, feature values, and scores and such. So, so it has a variety of use cases across so many domains. Like it's not like you can pick finance, retail, healthcare, and ML model monitoring, and so many categories of use cases. That's the power of Pinot. At a high level, this is the system architecture. So we want this. So the Pinot was built to be able to scale horizontally, right? Like as your data grows, or as a use case, get more users for the use case, you want to scale your architecture. So these are some basic components. So we have servers which are actually serving those queries, which have the data located in them. We have brokers to fan in and out from the servers, getting the queries, actual queries, and then Zookeeper for state, and Pinot controller for cluster management and like a coordination orchestration. And if you look at a Pinot, the Pinot table or Pinot database, we call it as a table, nothing fancy. So the data or the Pinot table is broken down into data is broken down into smaller units called partitions or segments, right? So segments, a unit of data, and these segments are spread across these servers. So when I say segments, these segments are the ones that actually hold the data, and they have the indexes and things like that to make your queries very fast, right? So the segments contains like rows of data. You can think of rows of data. So that's at a very high level. Although I'm not going to talk about these aspects, I'm going to talk about minions, which will come in a bit. So yeah, why is Pinot so fast? Is like yeah, we're able to partition the data into segments, and then we have really smart indexes that can actually prune the amount of data that is scanned for the query. So even if your use case requires a large scan, we have indexes. We have indexes where optimized to scan as less as data as possible to answer your queries. Just to give an example, right? So that's at a high level, like why it's so fast. The smart indexes, right? And a column architecture. So before going into Pinot, let's look at like what are the operations in Pinot, right? We can look at the operations, and then we can see where Minion actually fits in. So there are three operations, fundamental operations. The first one is the data ingestion. So obviously, when you want to query the data, you first need to ingest the data, right? So you need to ingest the data. It can be either from a batch source or a streaming source or whatever, right? So, and there are so many sources that are available, and data can come in various formats as well. So data ingestion is the first operation. Now your data has been ingested. Now we want to update the data, or we want to maybe remove something, right? Like say GDPR is one example that I've given here. Say you want to purge some records, remove some records, or you want to update some record, right? So that's a data update. That's another operation. And the third one is data reformat. This is a very important operation actually. So typically what happens is that when you have, say, you onboarded onto a Pinot table, your data is coming in, and your use case, I mean, your table is answering those queries. But over time, you have a large volume of data. The data pattern changes, query pattern changes, and now you want to scale, and that's when you might want to repartition your data. You might want to change the shape of your data, or you're adding a bunch of new indexes, or even like if you want to do some schema evolution, right? Like any disruptive changes to the table. And also the other very typical use case is you have segments, as I told you, right? The size of the segment is really important for the query performance. So if you have really large segments, then you're not using much parallelism. If you're using really small segments, then it bottlenecks the metadata like Zookeeper and stuff. So the size of the segment is important. So for various reasons, you might want to reformat the entire table so that you can optimize for your query performance. So this is the operation. So before going to minions, right? Like let's see how you would do these operations, right? Like how would you perform these operations? So when you take data ingestion, there are two types of tables. In fact, there is a third type as well, but we'll focus on these two types here. So we have a real-time table. So real-time table, it pulls the data from a real-time streaming source, such as typically Kafka or Kinesis or whatever, but Kafka is a common source. So we have the servers that I showed you in the beginning, the servers themselves pull the data from the Kafka source. So if you set up all the Kafka configurations correctly, then it's going to pull, servers are going to pull the data from the source, and you have the partitioning schemes there. If you have an offline table, so offline table doesn't mean that the table is offline or not available. It just means that you have a batch source that is actually populating this table. So if you have an offline table, you want to populate the table with data from a batch source. So typically you need to build like a dedicated pipeline or a workflow. It's either at Spark or Hadoop or whatever. And I mean, we do provide a bunch of APIs to push the data, but then you need to actually build those pipelines and maintain these workflows. This is without minions I'm talking about. So for data update, as well, like we have for real-time table, the servers does upserts or dedupe, those kinds of operations. Recently, I think deletes were also added. Whereas for the batch ingestion, you have to if you want to replace. So typically, we have seen like use cases, at least at StarTree, where the customer uploaded a bunch of files. They have like a source directory which has a bunch of files, and then those files get updated, get replaced with new files, or they get updated, and then we have to pull those files again. So re-ingestion is one. The offline, if it is an offline table, you have to do re-ingestion or replacement, right? And again, you have to have your own workflow or pipeline to do this job, right? And reformat is again, so typically when you want to do a reformat, then it means that your entire Pinot table, you need to look at all the segments, read all the segments, and then based on your table configuration or index configuration, you have to create new segments out of it. So it's like you're going through all the segments of the table and reformatting your data. So again, read data re-ingestion replacement. Again, you need to have workflows or pipelines to do that. Right. So as you can see, like wherever the work involved, which needs a dedicated pipeline or workflow, like typically like the batch ingestion or a reformat, or even update like in GDPR kind of updates, right? So for these operations, just a moment. Yeah, for these operations, you need to, the main pain point is you need to build and maintain complex pipelines, right? You might wonder, like maybe you can build it like one time and then be done with it and throw away. But then oftentimes you might have to use that pipeline periodically. You need to do some backfilling or any of those things. And the issue is that when you build those pipelines, now you need to maintain those pipelines, like, ensure the correctness, scalability, failure handling, debuggability, so many things, right? Observability, like you have to invest in a very small team or to manage those pipelines, right? And the other thing is also like I showed about reformat. So data reformat, at some point in time, you might have to, do that. Like it depends on the use case and how your data is growing. So when you have to do that, like these operations can be complex because you have to do repartitioning and in a way that you don't disrupt production traffic, right? So if it is done outside the ecosystem, so that is also a complex part operation. So broadly, these are some challenges. If you don't use Minion without like minions. Like I haven't actually gone to the Minion part yet, but yeah, normally how you do it. So we need like better solutions to handle these cases. And when we looked at the key considerations for the ideal solution, is we wanted to this is a very, very specific operation, right, for Pinot, where you're pushing building segments or pushing data into Pinot. So we want to keep these operations as simple as possible. So minimize the use of external systems like Spark, keep it minimum and simple, minimize those operations and keep it simple. That's one aspect, like Spark tuning and those, it becomes quite complex after a point in time. And the other thing is unification of control. Like we wanted something that integrates well with Pinot ecosystem, and we're able to use the building blocks of Pinot, for example, to do atomic swap or consistent push. where you have a batch of data, and when you want to actually ingest, you want to do it in a way that is consistent, all or nothing guarantees, and so on, right? So we wanted to have some way to unify control across all these Pinot operations. The other is separation of concerns. So we also want, so you have existing components that is already actually serving traffic, production traffic. We don't want to impact those components. So that's another key consideration. So now let's look at minions to the rescue. So what are minions, right? So Minion is, yeah, it's another component in this Pinot ecosystem. We can think of it's another system, right? So this is like a system or a machine which is meant to do computationally intensive tasks, background tasks, computationally intensive tasks without impacting your production serving system. So, and minions, depending upon the amount of work that you need to perform, you should be able to throw in minions, right? As many minions as you want to get this job done. So it should be like elastic and pluggable and scalable as well, right? So Minion is like native component which is part of the Pinot cluster. It can talk to the controller. I mean, that's the controller and Minion are the ones that work hand in hand, which you will see in a bit. So in a bit, actually, like I'm going to also explain internals of how these minions are actually used through the Minion framework. But before going there, I would like to share some use cases at StarTree that we use Minion for, how we leverage Minion. So the first use case is the file ingestion task. So if you take the example of the batch ingestion, right? So you have the data across various file systems. It can be S3, GCS, ADLS, and so on. So we build this file ingestion task so that we're able to ingest the data, ingest files from these sources, which can be in so many different formats, which has these key features, right? So when you have data at those sources, we want to process and ingest the data exactly once, right? And the other thing is that we also have capabilities in the ingestion framework to do pre-processing of data. We can do transformations, merges, and partitioning the data, and sorting the data, and so on. And typically, when we create the segments that I spoke about, right? So you will have the configurations of what kind of indexes you want for the segment. Whether you want like a sorted column or inverted index and so on, right? So all these kinds of things are taken care of in this in this particular task. And we replaced I mean the Spark and with this file ingestion task. So the file ingestion task is like a generic file. It's a generic task which can ingest from various different sources, right? So once you have this building block, you can use it to ingest from various sources with different formats, right? So I'll be talking more about these things, like how this works. So I'll go to the next part for now. So this is one very powerful ingestion task. We do have other types of tasks that read from like BigQuery and Delta Lake and so on. But I just wanted to show an example of an ingestion task. Just continuing a little more. So there are three types of broadly three categories, three modes for this task. So we use this to do bootstrap. For example, if the customer wants to backfill a certain or even bootstrap or upload a set of files like one time, they can use this task. The second one is called sync mode, which is actually a powerful mode actually. So here, the customer has input directory, which can be S3 or GCS or whatever, and they want, so the input directory can change, like they can add files update the same file or remove files, and we want that to be synced with the Pinot table. So we kind of have a one-to-one mapping between file and segment, but there is like a manage Minion task that keeps looking at this input directory for any changes in the input directory. And if there are any changes, it goes and syncs the input directory folder to the Pinot table. So it's always kept in sync. So this is a very powerful mode like some of our customers use. And third one is incremental ingestion. This is not the sync mode. There are no updates here. There are appends. New files are added, ingested, and the task detects those new files and ingests those files automatically. So these are some modes and scenarios that our customers use this ingestion task for. So yeah, so that's one example of an file ingestion task, the Minion task that we built. The second one is a very powerful task, segment refresh, which I mentioned to you about, right? Say when we want to repartition the data, say we want to repartition the data or merge segments, split segments, reduce the size of segments, increase the size of segments. Basically, you do all these things so as to meet your query performance, to get a better query performance. We use this segment refresh task for that purpose. And so what it does is like this task also runs in the background, and it's automatically able to detect that there is a particular configuration change. So the source of truth for a Pinot table is we have a table config which has various sections and how your index should be laid out and configured, what kind of tasks. So that table config has the details, and this particular segment refresh task, it's able to look at your current set of segments in the table and look at the table config, and it's able to say, okay, there is something different. So the table config was updated with a new configuration, a new partition, whereas the segments are not don't adhere to that. And it's able to detect this condition, and it's able to pick those segments which don't meet those adhere to the table config and recreate those segments, right? So that it actually meets the table config. So this is kind of, it magically does, when you kick off this task, it detects this change, takes all these segments, atomically replaces them with no impact, impact to the production, and then it creates this new table, a set of segments for the table. So this is a very powerful task which we very often use actually. So oftentimes, like if you can think of like real-time tables, the rate at which the segments get filled for real-time table depends upon the ingestion rate. And sometimes segments are too small, right, to start with. And very small segments, with very small segments, you have many segments that puts pressure on Zookeeper and metadata. So we want to merge those segments and make it larger. So these kinds of tasks can like automatically look at this, and then you can set a particular size of segment that you desire, and then it detects this difference, and then it starts building those segments. So this is another very powerful task that we use. And as I said before, like it supports various types of operations. Like we can do time-based partitioning or column value-based partitioning. You can merge segments to make it larger or split segments to make it smaller. And also like any index changes as well. Like when you make changes to their, add a column, remove column, any kind of disruptive changes as well. So this is very like, often used, this task is also often used. So these two examples wanted to demonstrate like the capabilities that you can do with a Minion. So if you look at it, both are like really compute. They compute, you're creating segments, reading, IO, and compute heavy. So these are actually done outside. They're done in Minion systems, the Minion machines, but they don't impact the production traffic, right? They don't impact all the heavy duty work happens in the Minion, which we'll see in a bit how it happens. So that's about the refresh use case. So now let's look at now that we have seen these use cases, right? Let's look at how does it actually work? Like where does this work happen? Like how the work is kicked off and where does it actually happen? So just to give a very short intro to the task framework. So the Minion task framework is built on the Helix task framework. So Helix is Apache Helix is used in Pinot for cluster management. So any types of like when a node goes down or when a new segment gets added, you want like you have like so many systems like brokers and server and controller. So we use Helix, which internally uses like Zookeeper to do the state management, messaging and state management. And the Helix task framework also gives a DAG, a workflow framework to us to do even task scheduling, where you can build a dependency graph as shown here, and then you can submit the workflow. It goes into a queue, and then the work gets submitted to the machines, like typically a distributed task scheduler. So it provides that framework as well. Although for the Minion task framework itself, we don't need like a DAG, a complex DAG here, which I will show in a bit, like what's it composed of. So yeah, so the Minion task framework is a more simplified version. So we don't use the DAG as such. We have only two levels. So you can think of this as one is like the brain as in the controller that I've shown here. So one is like decides how you're going to split the work, whatever the work is, which we'll see in a bit. Whatever the work is, how to split this work across all these minions, right? One example is, I mean, if you have like say several thousands of files to ingest, now how do I split those files across all these minion tasks to get the job done? Like how can I scale and what how do I distribute the work? So that is done by the task generator, which runs in the Pinot controller, part of the Pinot controller. And the other part is the Minion worker. As you can see, the Minion worker, we have the Pinot task executor. So the Minion worker or the executor, that is the one that actually does all the heavy duty work. So for example, the task executor is the one that actually loads the source files. It reads the rows or documents from the source files, reads those files, and then builds segments out of it. I mean, like building indexes and so on, right? So it does the heavy duty work, the Minion workers. And you throw in as many workers as possible, like as you want, like to get the job done, right? Like as quickly as possible. So there are only two levels as opposed to the DAG, which the Helix task framework itself offers. And once you have once you define like this is your task generator and executor, and this is how the tasks are going to be created. Those tasks are put into the Helix scheduling system, which picks those tasks and distributes them to the Minion workers, which you will see in a bit. So the other aspect is like with any distributed systems, like things will fail. So you need to build your system such that you handle those failures, right? So here, Helix itself has a retry mechanism to retry failed tasks, but we don't use it because each use case that we saw, even those tasks that you saw, right, file ingestion or segment refresh, we want to handle failures in its own specific way that the use case actually needs, which I'll talk in a bit. Like I'll give an example of that. So this is the picture of a task generator and executor. So typically, like when you have when you want, say, let's take the example of the file ingestion task, right? Say we want to write an ingestion task that actually takes those source files and then creates segments out of the source files, right? So what happens is in the task generator, so it exposes an API, and then we have to implement the API in the task generator. So what we do is that we get the context of the task. We typically the context you can pass in like what is your input directory and how to access the directory and so on, right? So the controller or the task generator has enough context or enough information to know like what's there in the input. like how many files are there. I mean, whether it was updated recently, you have name time and things like that. So it has those details. Now, this controller is going to decide, okay, so I have these files. I mean, these are all like Parquet files or whatever, right? Whatever the configuration that you specify. Now I have these files. I'm going to distribute the ingestion of these files in a certain way, so that whatever the optimal way that it chooses, right? Like given so many minions and like how you're going to split the work. And so it's going to create Pinot task config. Like, so what this means is that for each of those minion workers, there is a dedicated Pinot task config. So when you say list of Pinot task configs, each Pinot task config can go to a separate minion worker. So for example, if you have, just to give an example, if you have 1,000 files and you want to give like 100 files for each minion worker to ingest, so each Pinot task config would have like 100 files as an input, and then it's going to the minion worker. The minion worker is going to look at this task config. Okay, these are the 100 files that I need to ingest, and it's going to do the job, the heavy lifting job. Right? That's the idea. And the other thing is that the controller also, the controller is the one which is intelligent. So it determines what to ingest, what not to ingest, how to smartly do things, and so on, right? So the minion is more, the minion blindly follows like what is given to it. So it doesn't do any of those smart things. It gets the Pinot task config. All it does is, okay, this is the task config. These are the inputs. I'm going to do this job of segment creation and upload to the table, right? So we'll see an example actually of task generation in a bit, like how what is intelligent in the controller. So, and once you submit, create a task, it goes to this Helix task framework. It's put on a queue, and then it's put on to this minion queues, and where it's being picked up, right? And Helix does it. It has some basic level of monitoring of task failures, task state, and so which we use. The task execution, as I said before, execution happens on the minion worker. It does the heavy lifting work of reading those files, doing any compute, or building those segments and pushing it to the table. So it does all the heavy lifting work. And generate segments and uploads, right? So yeah, I think I mentioned about this. And the other thing is, like, we also have, so each minion machine or worker also has multiple threads. So you can even set up how many instances you want, task instances you want within a particular worker. That's another lever for parallelism. So if you want to utilize the resources of that particular machine, you can have like multiple instances of workers to run in parallel. So you have parallelism by throwing in more minion machines, as well as within a minion machine, you have multiple threads that does this execution. So you have
Manish,
both these levels. Yeah.
we do have I think, timely question about a grouping of tasks. Can you group tasks together, meaning perform one small and one huge task on single minion at the same time based on some heuristics?
So in general, all the minions are homogeneous. Homogeneous as in like they have the same, they are all like similarly sized. So in general, at least at StarTree that I've seen, is we divide the work, equal units of work to all the minions. So if that was a question, right? So we don't have like heterogeneous, at least like we haven't explored that route of having heterogeneous minions where depending upon the minions capacity, we assign the work, right? So that part we haven't, that intelligence is not there yet. So we assume that they're all like similarly sized and then assign equal amount of work. And at that point, actually, we don't even know, like when we actually read, so one example is like a Parquet file, right? Parquet file, usually it can explode or expand into, like, if it is heavily compressed, you might think that it is like 1 gig, but when you expand it, it can become 100 gig. We don't know, right? And if you have like, say, at the generator level, we're obviously not going to decompress and look at it, right? So we might think it is 1 gig, and sometimes it can be skewed, and one minion can end up getting a lot of work. So it's possible. Good. Sorry.
Yeah, no, I think this is the I think this is a good answer. So essentially, it is homogeneous. So you're running like a one type of tasks, and that's
Yeah.
how you should think about this.
Yeah. In general, yeah, that's the thing. But that's a good question. Like, yeah, does Minion the second? I'm just sorry, I missed I didn't look at the
Yeah.
Slack. Yeah. Second
As
one
Minion
is
framework supports multi-tenancy.
multi-tenancy.
Yeah.
So yeah, currently it doesn't support. Um, we don't have that multi-tenancy for the Minion. So like I mean, if you have a bunch of tables, they all use the same resource pool. So that's one thing. Like the Minion is a global component. Like it's not, at least at the moment. If you have multiple tables, like they all share the same Minion resource. So we don't have multi-tenancy at the Minion level. Asking.
Yeah, I think we can postpone some of those questions and troubleshooting until Q&A. But I thought that was a timely question when you were talking about types of task. Brian, could you kindly wait until Q&A session, and maybe you can unmute and talk about your problem. Thank you.
Sure. Yeah, we can discuss those things. Yeah, definitely. So yeah, where was I? So for the executor, you can extend the executor, and that's how the executor functions. I think I talked about it. Segment creation and upload. Failure handling is really important here. So obviously, when you have in distributed, I mean, say you're ingesting like 50 terabytes of data. I'm just giving some number, right? There are so many tasks that are created. Tasks will fail sometimes. Some files might be ingested. Some files might just fail without getting ingested. So at this time, we don't want to say we have ingested like 30 terabytes. Now there is a failure. We don't want to again rerun ingestion and re-ingest all those 30 terabytes, right? Like it's a waste of resource and time. So we have each ingestion task has its own way of handling failures. So in this specific file ingestion task, what we do is we also have checkpoints. So wherever we ingest files, we also checkpoint saying that the file has been ingested, right? And so I mentioned about the task generator being intelligent, right? So when say there are you triggered an ingestion, and then say 100 files had to be ingested, and then like 90 files were ingested, and 10 files, like the Minion crashed and we couldn't ingest 10 files, right? So this particular task has an ability to run on a cron trigger. It can run like schedule itself and run like every couple of hours, or you can even manually trigger it, right? So say that after the failure, the user saw, okay, there was a failure, and then re-triggered it. At this point, this controller is going to read that checkpoint. The checkpoint, we actually store the checkpoints in Zookeeper, right? And it's going to read those checkpoints, and it's going to detect saying that, okay, you've already ingested those 90 files, so you can skip that, and it's going to ingest only the remaining 10 files, right? So that's one example of how we do failure handling for file ingestion task. This is also exactly one semantics, right? And the other one is like for segment refresh task as well. Like we have a way. We want like all or nothing when we're actually taking the segments of the table and trying to repartition or merge or split. We want to atomically replace the segment. For example, the segment refresh task picks one segment and breaks that segment into two segments, right? Say we want to split. And what we do is when we actually create those two segments, we want to atomically swap that one segment with those two segments. And there is a way segment replacement protocol that we use, that Pinot has, that ensures that all the queries either go to the old segment or they go to the new segments, the two segments that we created. So there is an all or nothing. So, and if there is a failure, it continues to go to the old segment. So some of these, like the failure handling, very specific to the task. So Helix doesn't know about these things. I mean, With Helix, we do know that whether the task was successful or failed. So we use that information to know the status of the task itself. But for file ingestion task, we look at like specific information in Zookeeper, say checkpoints, or segment refresh task. We look at lineage, things like that. So they handle like these tasks handle failures in their own way. So and yeah, when we have when we want to do like say the ingestion, like we say large scale ingestion, or we want to use this framework, we obviously need some level of observability to know what's happening. So we use there's another design principle that I talked, unification of control, right? So we use the same Pinot controller, the management UI, which has a bunch of APIs. And from those APIs, you can figure out like what is the task state, like progress, and so on. So, and there is also a way to trigger like stop tasks or delete tasks or start tasks, schedule tasks. Those are also available via the controller UI. So we have some level of observability through these APIs that we can use, although we want to improve this actually. That's one thing. And the other is minions. The minions also, we also have metrics that are emitted. Those metrics are exported, and you can use those metrics for observability, right, for operations purposes. So we also have, and there is a detailed doc on them. So this is an important aspect actually. So auto scaling, so I mentioned about like minions being like you have minions to do the work, and if you look at these batch tasks, like sometimes customers may do it like one time, or they might schedule it during some time of the day, and so on, right? Like you don't need to have all those minions sitting around all the time, right? So you want those minions when actually you start this job, ingestion job. So at least like in StarTree, what we did was like we had this auto scaling mechanism where we look at the task queue. Like when any new task, ingestion task comes in and creates like a work for the minion, we look at the task queue. We also give the min and max, like how many minions to provision, right? Like sometimes we say, okay, maybe we want like 100 minion machines. That's what we want. So this particular this auto scaling mechanism, it keeps looking at the queue, and if it finds that the queue is growing, it's going to just provision those many minions. It's going to there is a very simple linear scaling way of scaling, and it's going to provision those minions to do the work. And once the queue is drained, it's going to bring it back, those 100 minions back to like 1 minion. So basically, with this, you actually control the cost. You don't need to keep those minions around for forever. So using the scaling, you can scale up and down and save on the cost. So that's one thing we implemented at like StarTree. So having said that, there are many interesting things that are also happening which we want to improve. Some of the things that I want to share, like the current work, is that I don't know if you've used the Minion like batch ingestion, right? Like usually when we use this ingestion, we typically provide like number of docs that we want in the segment. But number of docs doesn't mean much actually, because the segment can be heavily compressed or it can blow up. We don't know, right? So we actually at least StarTree, we worked on a feature where you can set the desired segment size. This is something that's available on the real-time side actually. So you can set these segment. I can say that I want the segment to be of like 200 meg, and then set the size, and then we have an adaptive way to figure out like how to get to that size. So we developed that feature. The other is like consistent push and refresh segment replacement. So there's another use case where we want to like segment refresh has the atomic swap, a local atomic swap, but some customers actually want like when we ingest say a batch of files, they want to do all or nothing like switch. Like even if say one file fails to ingest, they don't want to use the table, right? So they want an all or nothing. So for that, we're working on the consistent push by using the segment replacement protocol actually. It's available in open source, but it's not there in the Minion task, itself, like to use it at a global level. And refresh is another case where there's a use case where you have the existing table. Like there are use cases where you have a table, and every like month or so you want a complete swap of the table. Like you have a new table that replaces the old table, complete swap. So that's another thing we're looking at. And also the observability for ingestion and refresh. Like we do have observability at a task level, but it is not, sometimes it is not intuitive. For our customers and use cases, we typically want to see observability at a more higher level. Like when you have like files, some 1,000 files that are there, or in terms of size of data to be ingested, we want progress to be, okay, these many files have been ingested, some estimation of how much time it's going to take, rather than at a lower level, like a task level. So we want we're looking at how to make it more intuitive for both ingestion and segment refresh, actually, because these are all like long running operations, and we need like good observability metrics to figure out what's going on, progress. And some future work we're thinking about like is we want to, so right now some of the things are coupled together, like so we have connectors, and then we have like file ingestion, SQL ingestion, and so on, right? So some of these are intertwined, like the foundation pieces and the connector, source specific connectors are kind of intertwined. And so it takes amount of time to add a new connector, say a MongoDB connector or so on, right? So it takes a certain amount of time, because like there's no clean separation between the foundations and the connector. So we're working on separating those foundations so that they can be leveraged, and adding a connector becomes really, really easy and faster, like the order of days, right, to move fast. So that's one thing we've seen. Even if open source, you look at that, there are some tasks which do the same thing, but there are two separate tasks, right? And the other one is like pre-aggregations. I think this is another thing, like some customers want to actually join, like even before the data is ingested, they want to have some sort of like materialized view and joins across some sources and then ingest. So that's one thing we're looking at. We will be looking in the future. And the third, like I think someone asked here about the multi-tenancy. So we want to have some sort of resource isolation for the tables, especially as like we head into SaaS, right? Like multi-tenancy becomes really important for ingestion as well, for if you want to have a SaaS provisioning across customers. So that's one thing. And there are many improvements that we can make in the auto scaling as well. So once you have like heterogeneous types of machines, like how to scale up and down. So these are some things that we're thinking about. So I think I'll stop here, and I'll take questions. I'll spend some time on the questions. Does it make sense?
Yes, it does. I think it's if you have a question, if you want to read the question, you can like, if Robert wants to talk about his question specifically, you can unmute yourself. And if Priyank wants to talk about his question as well, he can unmute himself.
So I can go in this order.
Yep.
So Prachi's question, if I read, you can correct me, Prachi, if you're there as well, like the ohms, right? Huge tasks.
Out of memory exception.
Out of memory is we have also seen these kinds of things trying to run concurrently. So that's the thing, right? Like it's so the reasons for out of memory is actually, these are some things that we have seen experienced here. One is like if you look at the segment processor framework, right? Like especially with Parquet, when you are ingesting Parquet files that typically seen, and say the Parquet file will look really, really small. Like it'll say like 20 meg, and then say we feed in like hundreds of those files into one Minion task, and we allocate like record readers, right, for those Parquet record readers for those files. They go into the Minion and then runs out of memory. Actually, that part we actually fixed. The way we address that issue, like I'm just telling you some instances, like some examples of what kind of issues we ran. So I don't know what version of open source you're using, but we fixed it in open source as well. Like The problem was that we allocate all the record readers eagerly, and they are all sent down to the processor framework, and they just continue to take up memory while we are actually building the segments as well. So the way we fixed that was like we use only one record reader at a time. We allocate it. We transform, map, and do whatever we want, and then we close it. So at any point, only one record reader is actually open. This was actually fixed like about a few months back. So that's one out of memory thing we faced. The other out of memory issue is like sometimes your segment becomes really large and then we run out of heap. For that, we have this adaptive segment sizing where we can control the size. So that's another way we fixed. But this is definitely a pain point in the sense like the das generator that generates the work, it doesn't, I mean, we haven't read the files and know like how it's going to uncompress and all that, right? So those issues will be there. So we'll have to do some level of tuning as how many files that we give each minion. So some level of tuning is required. But again, at least StarTree, we saw the patterns of wounds and then we fixed those patterns. So does it answer, Prachi?
Yeah. We mostly see it due to like so for us, it's string issues. So maybe a segment has so many unique strings. So he gets full due to different strings, even if the strings are like sorted.
I see.
If few of the jobs come and fall on the same minion and each segment is of size 5 GB or more, then runs into
So I think that we have some plans. We want to do this in open source as well. I think desired segment size, if it comes in open source, I think that will address the segment size problem. You will be able to control, right? So that's one thing. But of course, we have also seen like direct memory also. Like sometimes there is a column where they put in like the string size is like some 5 meg or 2, whatever, right? It's really huge. And then if the data distribution is skewed, like we have a very huge segment and we run out of direct memory. That's even harder to solve. Yeah. So I'll go to the next. Robert's question, if segment refresh, if I increase the flush threshold in my table, will it know only to merge and partition? So this is a StarTree extension. Maybe Robert, could you give me more context on this?
So you were saying that the segment refresh task is able to like merge and split segments based off of like the table config, right?
Yeah.
And like the context say, you're doing like you have a table that is also configured for upsert, where
Okay.
the segments are partitioned.
Oh, actually, yeah, it doesn't work. That's another. So it doesn't work on upsets, the segment refresh.
Yeah.
So if you have upsert configured, it doesn't work. Yeah. So we haven't implemented that yet. Was that your question?
Yeah. Another quick question is that about saying minion tasks. Has there been any talks or plans about making the minion tasks composable? Because like sometimes I have needs to like, or what I would like to run like multiple tasks, like for a table where, say I'm doing compaction, but I also want to like merge, after compaction, like.
Oh, so I think what you're asking is like actually having this DAG in the sense like here, right? Like right now, we are not able to compose multiple operations in the Minion framework, right?
Yeah.
Like after, in fact, even for consistent push or segment replacement, we had to do something similar. So, I mean, I think that has come up. We want to do that actually, but yeah, we haven't gotten to that. So you're saying that here you want to compose a graph where you want to do some task and then they all converge after they finish it. definition. They have one more step, and like a graph, right? Dependency graph.
Yeah, because right now, like if you wanted to have like the features of different tasks, you have to kind of create a new task that does both, right?
Correct. Yeah.
All of the different features that you want in your task.
Correct. Yeah. I mean, to compose so that once this is done, you start the other one. Yeah. Yeah. We haven't gotten to that, but I think we have also seen like the need for that, just because it needs some work on the foundations in the Minion task framework itself, right? To support that, to be
Yes.
able to compose that. Yeah. We haven't gotten to that, but I'll make a note of that. So what are the advantages of using Minion-based triggering? Yeah, good question. So the Spark, so the Minion task framework. So one thing is that, like I explained here, right? Like the key considerations, the challenges, right? So I mean, definitely use Spark as well, Airflow DAG, but then you would have to manage the DAG. Like you need to manage that, keep those pipelines, manage those pipelines, and maintain those pipelines, right? And also handling scale. Like how do you? I mean, like all these kinds of issues, you have to deal with it. Versus like if you just pick the open source. I mean, we have like at least like a couple of built-in tasks like segment push and generation task. I think there's real-time to offline and merge and roll up, some of those tasks. So those we can use the Pinot cluster itself, and you can leverage those tasks, and which also have, I mean, which takes care of handling all these kinds of things, right? Like instead of you having to manage via your own Spark job, you can leverage what's already there, right? So that's one thing. And also like it's maybe Priyank, you can also talk about like, do you have, is it something that Spark job or something that you already own, you're doing this, or like what's maybe you can talk about that as well, like.
Sure, Manish. So we have an offline table, and what we do is we use the Spark job template that is in open source
Okay.
for push. So we'll create segment and push directly. And then what we end up seeing, like we would like to have atomicity of that operation, where we push data to a table. So what we end up doing right now is we create two copies. So there's an older version and there's a newer version, and then we basically do a swap of the index in the calling layer to like, hey, like at this instance use this version, and at another instance, like the later time, use the other version. So that's what we end up doing right now. And so we are using the segment push. I'm forgetting the actual name.
Segment replacement.
Yeah, not segment replacement. I'll have to look
Metadata
it up.
push.
Metadata push. Yeah, that's what we do. So
Okay.
like seems like it's pretty much like what Minion is doing pretty much the same. And with the Airflow DAG, basically the additional advantage that we get is so our data in the input data is in a different format. It's again, I mean, it is Parquet, but it is not partitioned in a way where it will give a better performance on queries. So we end up doing a bunch of other stuff before we actually push the segment. So if you were to like use Minion, like if I were to propose these users to go towards Minion, like what advantage do I get?
So yeah, definitely. So one is like, so it's, I'm not saying like there are some customers who already have a Spark cluster and they are already doing these things, right? So I mean, if you're managing your own pipeline, that is one way. I mean, it's still possible. Like say if you have a fixed ingestion job and it's running and it's fine. I'm saying like with respect to like there are customers who don't want to do all these, who don't want to own those pipelines. Lots of customers who just wants to like have self-managed flows. For that, I think the existing Minion tasks are very useful. But even for the other things, like if you have use cases where you want to merge segments, have you ever had to do those kinds of things?
We haven't done that yet. Actually, we
Yeah.
haven't even explored it yet. That's something that we plan on looking next couple of weeks.
Okay. So those kinds of things, like the merge rollup task is already there, right? Like you don't want to, like you might want to reinvent that again, like on your side. Like if you can leverage the merge rollup, if it's doing the job, at least the basic job of compacting segments or like merging, splitting segments, then you can take advantage of that, right? And you don't, yeah. So it's just that you don't need to manage and handle like both code as well as those pipelines.
Yeah.
So, but it's case by case. I mean, like some customers want the control to do it in Spark. Many customers who don't, they don't even want to touch this. I mean, like they don't want to maintain pipelines and things. So,
okay.
Yeah. So, any more questions? Any questions?
Hi Manish, I have one or two questions. First one is just around Minion task execution. Is it like uh, uh, based on the event and scheduling both, or is it only schedule based task execution?
Good question. So it has both. It has both a schedule. So you can set up a schedule for the task, and it's going to run on that schedule, right? Like you can say like every couple of hours or whatever the schedule that you want, right? That's the managed. So one good example of the schedule is that sync mode that I spoke about. I just want to show that, just to show an example. The sync mode, right? Like sync mode is what um, there is a task that runs on a schedule like every 1 hour or so, and it looks at the input directory to see like what has changed and sync with the Pinot table. So that's a schedule. But we also have an ad hoc where it's not a schedule, but then we have an API where you can submit the task and it's going to just run one time, like for one-off ingestion or ad hoc, like a bootstrap or something like. So we have both these modes. Does it answer?
Thanks. So how aggressive we can go with like a schedule itself? Say I want to configure it every 5 seconds or every 3 seconds. Is it possible and is it scalable?
Good question. I mean, you can scale, like you can set those configurations, right? But if you think about the consequences, if you look at like what the task generator is going to do, typically it's going to go and look at your S3 bucket, like it's going to list all those files. Say you have 10,000 files, right? Now you have a scheduled trigger of like every few seconds, right? So typically, like when you schedule a task, I mean, the task is going to take a certain amount of time to complete, right? You might not want to run. You don't, probably it's not necessary for this scheduler to run like the task to run like every few seconds and create some new tasks, right? Like once it creates a bunch of tasks, maybe it's going to take some amount of time and then you can space it out. So if you do it like every couple of seconds, it's going to go and list those files on S3 bucket, right? And it's going to create some issues, like 10,000 files it's going to list, like figure out like what to, and finally it might end up doing nothing. It's going to probably say that, okay, I've already scheduled these many tasks, let me wait for it to finish, depending upon how you're going to implement that, right? So yeah, definitely it allows you to run like as frequently as you want, but there are consequences, right, of that.
Right. Yeah. Thanks. The another question is like I remember you mentioned about using a minion to get a data from a BigQuery. So is it also possible to query, say, relational databases like MySQL or Postgres to get our data and push it into like Pinot itself?
Um, right now it is not. So I mean, in StarTree, I think we implemented like for BigQuery and Delta, but I think we don't have one for MySQL. Yeah, I mean, like whatever you mentioned, Postgres, MySQL, not yet. So that is why again, like if you look at this work, right, we want to. The problem is it takes. If you look at all these connectors, like it takes some amount of time to implement and push it to open source, and it takes some amount of time to develop those tasks and things. So we want to actually invest here so that all these new connectors we're able to easily add like in a couple of days, right? Like be more agile. So, but right now it's not there.
Right. Okay.
MySQL and Postgres, yeah.
Yeah, because I was thinking on the lines on something we have Kafka JDBC connect. So
Okay.
similarly, you have say Pinot JDBC connector or something like that, and instead you can directly get a data from the database itself. You don't have to leverage Kafka in between.
So
And
CDC stream is there, like
CDC is one of the way, but then still you have, in my understanding, you have to use a Kafka, right? In
correct.
between.
Yeah.
Yeah. So if we
There's
have
both
something like
flavors in CDC and GDBC. GDBC pulling, CDC is kind of like pushing, so it just depends on the flavor.
okay, got
I
it.
think you're right that both connectors will works. Yeah, and yeah, Robert says that Pinot supports
DBCM
pulling.
is there. Yeah.
Yeah, so DBCM does both like CDC and
JDBC.
like a pulling. Yeah.
Got it. Right. So just to follow up on this, we have this which you mentioned, like the pipeline work to separate these two things, and then we can easily add new connectors. So is it like we have divided work streams right now, or is just the idea right now, and then in future we are going to work on it?
So it has to be scoped. I mean, like the proposal is there, but it has to be scoped. It does not like we haven't started any implementation or anything. It's still like a proposal phase, and yeah, it can take some time depending on priorities. But it is something that is like, because whenever, like you mentioned, right, when somebody customer wants, like when we want to add a new source, then it takes a amount of time and all that. So but we need to prioritize this work.
Got it. Okay.
Yeah.
Thanks.
Any more questions? Any even like comments or suggestions from your experience? Yeah.
It's
I'm muted. Yeah, again.
I would say from developing
go ahead.
Developing a task is pretty simple. You have to just implement only like a couple of interfaces, like the generator and the executor implement interfaces, and those aren't like too complex. It's easy to at least plug one in. Obviously depends on how complex your task is, right, and what it's doing, but it's from my experience.
Oh, you're saying sorry. So you're saying like implementing the interfaces depending upon how complex your use case or task is, right? Is that what you mentioned?
Yes.
Yeah.
I think like one case is like that's talked about in these type of presentations is GDPR and purge task, which obviously depends on business rules that could be easily like implemented into a custom task.
Correct.
Your own custom task, and it's easy to kind of build and deploy that into the Minion task framework.
Yeah, I think I agree. Like at least it's easy to implement the functionality. Some challenges you will face with respect to scale, right? Like it may be functionally okay, but then when you start doing it across like scale and how to tune it and those kind of things, that's when you have to do some smart things and figure out. I mean, the checkpoint was the stateful thing was actually it was very powerful, but it is also like anything you make it stateful, there is a complexity. So you have to clear this out. I mean, it should work correctly and all that, right? Yeah.
The file ingestion task, I did use that, and I highly recommend it. Works very well, especially the sync mode.
Sync mode. Okay, thank you.
Okay, folks. Manish, thank you so much for this insightful presentation. Really like that, and learned something myself. So don't forget to, if you're watching this as a recording or you have some questions that you want to ask, you can ask them in our Slack channel. I will put the link in in the comments here. And also, if you're in this type of jazz that we were talking here at the meetups, we are start promoting a real-time analytics summit, which is gonna happen sometime in May in Southern California. Northern California. I'm sorry. It's gonna be happening in San Jose. In May. So make sure that check it out, and if you will want to come, please, we're gonna doing this in-person event. It's gonna be really fun. Once again, Manish, thank you so much for your time. Thank you so much for everyone who joined us. My name is Victor Gamov, and as always, have a nice day.
Thank you so much for coming. Thank you.